Okay, the first question on the review asks us how many tiles does figure 0 have? So we look at our graph. On our graph, our x value is our figure number, and our y value is our number of tiles. So we look for figure 0. Figure 0, 0 on the x-axis is right here. So we follow it up. When x is 0, x being our figure number, what is our y? Well, if we look here, our y happens to be 4. So y is our number of tiles. That would be b if we were doing a linear equation. We would write b here. B equals 4. The y-intercept is 4. There are 4 tiles in figure 0. Okay, problem number 2. What is the rule for the following pattern? So we want to see how much this pattern grows between figures. So let's look. What's adding on? We're adding on a block down here, and we're adding on 2 blocks up here. So let's shade those. See if it still works over here. We're adding on a block. We're adding on 2 blocks. We need the rule. A rule is an equation. Equation y equals mx plus b. We know that it's adding 3 each time, so our m is going to be 3. And our b is our y-intercept. It's our starting point. It's our figure 0. So we've got to figure out how many tiles are in figure 0. How are we going to figure that out? Well, let's just follow the pattern. We added 1 down here. Let's shade this in. We added 2 up here. Shade this in. So what would the previous figure look like? The only thing that would be left would be the central portion of 4 tiles. So figure 0 would have 4 tiles. So this is going to be y equals 3x plus 4. So our rule for this pattern is y equals 3x plus 4. Problem number 3 asks us, for the point 1550, 50 is the value for the A, independent variable, B, dependent variable, C, input, or dx. Well, let's look at this. This is a point. We know that every point has an x and a y. Our 50 is going to be our y. You can look right here. 50 is the y. So we know it's not d. Okay, what do we put in? Well, let's think about this. Any equation that we could have. Y equals 3x plus 5. Just any equation that's linear, in this case. What do? Well, we put something in for x. So let's say x is 15. So that'd be 3 times 15 is 45 plus 5. Y. Well, we know that 45 plus 5 is 50. So y equals 50. We put something in for x. Our input is our x as well. So we know it's not input. Now, following along with this, if our x is our input, then that means y has to be our output. So we know that terminology. Now, output isn't one of our choices. So we're left with independent variable and dependent variable. But let's look here. Independent. Our independent variable is our input value. It's our x. It's our one that doesn't depend on the other one. Our dependent, y, is based on whatever x was. So our answer is going to be b, our dependent variable. This one would have been our x as well, so we crossed it out. So different names for x. We can have x, we can have input, we can have independent variable. Different names for y. Let's do x first. We have x, input, independent variable. Our y is it is obviously our y, it's our output, and it's our dependent variable. Okay, what is the y-intercept of y equals 4x plus 2? Well, if we know the format of a line, y equals mx plus b. In this equation, our m is our slope, and our b is our y-intercept. So we want to know what b is. Well, we're lucky. This one already follows the format y equals mx plus b. So we just have to identify b. B equals 2. That's our y-intercept. Okay, problem number 5. What is the y-intercept of 3x plus 5y equals 20? Well, we're not as lucky here. We don't have it in y equals mx plus b format. So we need y equals mx plus b format. So we want to solve for y. Solve for y means getting y by itself. So we're going to subtract 3x from both sides. And we have 5y is equal to negative 3x plus 20. Divide both sides by 5y. Y equals negative 3 divided by positive 5 would be a negative 3 over 5x. And then positive 20 divided by positive 5 would be positive 4. So that's our equation. Now we just need to identify our b, and in this case, our b is 4. So b equals the y-intercept which is 4. Okay, number 6. Give an example of a linear equation. A linear equation is anything in y equals mx plus b format. There are actually other formats, but this is the format that we know. A linear equation, the important thing about a linear equation is that it has an x in it, and it doesn't have any x's with an exponent any bigger. So there's no x squared, there's no x to the 3's, there's just an x somewhere. So, examples. We could have y equals 3x minus 2. We could have y equals 5x. We could have y equals 2x plus 1. Y equals x. Y equals negative x. All of those are linear equations. Okay, give an example of a quadratic equation. Well, a quadratic, this is a parabola. And a quadratic requires an x squared term. Now the format for quadratic is y equals ax squared plus bx plus c. We'll see a lot more of this as we come up later. This is very similar to y equals mx plus b for linear that we've been working with. You don't have to know this to know a quadratic. You just need any equation that has an x squared and no x's with an exponent bigger than that. So no x to the 3, no x to the 4. So we can have y equals 2x squared plus 3x minus 4. We can have y equals x squared. We can have y equals negative x squared, as long as we have the x squared in there. Okay, so knowing what we do for 7, number 8 should be easy. Which equation would make a parabola when graphed? Well, we want a parabola, so we want a quadratic. So that means we need an x squared. Which one has an x squared? C. It's the only one with an x squared. So it has to be C. 8 is C.